brought my two shoes and I'm wearing my.
Alright, so we're going to talk about z-scores. The huge topic in this class. You'll use it like basically through the entire year. We'll talk about z-scores. So a z-score is the number of standard deviations away from the mean. Positive is above the mean. Negative is below it. So I remember yesterday we made that chart and we put like +1 standard deviation, +2 standard deviations, +3. The like more technically correct way to say that would be z equals 1, z equals 2. But that's all it's saying. If z is -2, negative means below, 2 means 2 standard deviations, so we'd be like over in this area here. So I'm going to do like one example. I'm going to do a bunch of stuff with the example, and you're probably going to be a little confused on some of it. And then I'm going to do another one, and you're going to be like, okay, this is starting to make sense. And then we'll do another one, and hopefully you'll be like, okay, yeah, this is cool. But the first two might be a little bit overwhelmed. Just bear with me. You'll be okay. Let's say I gave you the average ACT score is 21. Standard deviation is 3. And a certain, I don't know, Joe got a 25. I'm going to ask you for 3 things. First one is to find the z-score, which we'll do. Yeah, I'll just do one at a time. First one's to find the z-score. When you find the z-score on my test or the AP test, you have to show the formula every time. Unless it's multiple choice, then it doesn't really matter. But on the free response, you'd have to show the formula so they can see that you know the formula. Or that I can see on the test. So the formula, and it's going to look goofy at first, is z equals x bar. It's called x bar. Bar on top, minus mu over sigma. So what that means is our data point minus the mean over what's sigma? The standard deviation. So you don't have to write this ever. I'm just like telling you what all those things mean because this just looks like a bunch of nonsense. I guess. Maybe it doesn't matter. So I plug that in for this problem. What's x bar for this problem? 25. What's mu? 21. Standard deviation or sigma is 3. My z-score would be 4 over 3. And I'm just going to, I mean, I can make it 1.33 or I can make it 4/3. Those are both okay. doesn't really matter. Why is my z-score positive? Go ahead, just show.
Because it's above the average.
Because that person did better. Joe did better than the average score, right? Okay, so Joe would be like here-ish on the chart, right? So that's the other purpose for z-scores. You could tell me right now what percent of scores is below this. You tell me what percent of scores would be below this, approximately. Like 84, right? This is all 50 plus this section's 34. You can tell me what percent is below this. You can tell me what percent is below this, but you couldn't tell me what percent is below right here without a z-score, without what I'm about to show you in your calculator. So that's another reason for z-scores is to do like the stuff in between the 1, the 2, and the 3. All right, the next thing you're going to do is find the percentile. Remember, percentile is the percent that are at or below. So will Joe's percentile be bigger than 50% or smaller than 50%? Bigger, because he did better than average. He did better than more than 50% of the people. So he's going to have a percentile of at least 50%. At least 84%, really, because it's going to be a little higher than that. So, I'm going to write this out here, and then we're going to get our calculators out and do it. We're going to do what's called normal CDF. We're going to go negative 999 up to 1.33. We're going to tell the calculator the mean. We're going to tell the calculator standard deviation. I know you don't have a clue what I'm talking about right now. Just write that down. And then I'll show you how to do it in the calculator, and we'll do a couple more, and eventually, hopefully, you'll be like, okay, this makes some sense. There's another one, like on a test, you need to write this out, you need to label the mean, and you need to label the standard deviation. So get your calculators out. And some people's look a little different, so we might have to kind of do this twice. But I'm going to hit second and then vars. So you see how above vars it says that distr? That's for distributions. We're looking at a normal distribution. So hit the second button and then the vars button, and you should get this menu. And then we want normal CDF. And some people will pop up with this menu, like it kind of prompts you, lower, upper, mean, standard deviation. How many people's did not pop up with that menu? So like a lot of people's it just says, well, hopefully yours, if you have your hand raised, it just did that, right? Okay. So we're going to all type in the same information. If you're doing this, you're going to put it like commas in between it, just like I just wrote down in the notes. If you're doing this, you're going to type in the same stuff, just you don't need the commas. So the lower is going to be negative 99999. I'll explain why that is in a couple minutes. The upper is going to be what Joe got. So Joe got to a 25. Basically, we're trying to figure out what percent of people got, I'm trying to say lower than 25. So lower than 25, I'm going from 25 all the way down to like negative a billion, or negative a million. Just to make sure I'm getting all the outliers or endpoints that might be. I know you can't get lower than a 0, probably lower than like a 4 or something ACT, but I'm always just going to go negative 999 up to whatever. So I'm capturing this and every single thing below. So I'm making this as low as I can make it. And then tell the calculator the mean, and tell the calculator the standard deviation. And if you didn't have that menu, you just kind of skip a step. Like you would just start typing right here and put commas in between the each of the pieces of information. And if you hit enter, you should get that number. You should get 90.88%. Yeah. 25 is Joe's score. Yeah.
It's above
There's a
7.
comma. Yeah, above the 7, there's a comma. So the negative 999 for now is always going to be there. Because we want to go down to the very bottom. So yeah, where does 25 come from? Oh, crap. Sorry. This is why people are confused, right?
Yeah.
Put 25 there. I'm sorry. My bad. I got my signals crossed in my brain. Okay, so where'd the 21 come from? 21's the mean. Where'd the 3 come from? Standard deviation. And then I have to take this extra step and hit paste. Some of you don't. But is everyone getting that number now? If you made it 25 instead of the one I screwed up? Okay, really good. If you got an error, bring it up. You put a minus sign instead of a negative sign. And then like you can say and then nice. You also have 2 to You did it right, you remember this a lot.
I think that's my first one.
Oh, look at that.
Yeah.
I just don't see it.
Any other issues?
Oh no.
Errors? Everybody good? Okay, then I want you to graph this or sketch a graph of this. Okay. It's just water, it'll dry. You're good. I'd rather you got the notes. Zoopy would be freaking
Yeah, I
out.
know. That's why I was like, okay.
Zoopy's probably mad that you spilled water in my
I know.
class.
If you walked in here right now, you
I know. It's a hard thing.
It's like screaming all the way in
I know. He can sense it. Alright, so the last thing I want you to do is sketch it. So we are trying to get an understanding of like what these numbers that we just found actually mean. So make a little normal curve. 21's your mean. Start doing your standard deviations each way. Really wants to be walking right now. Can you see okay from there? Well, then turn it. You can get up and turn it. Or you can remind me or whatever. Well, then tell me. Okay. So what I want on your graph, we got to, over here is Joe's score. And we need to represent this 2 ways. One is that x bar equals 25. And I'm going to write that like down here below because that's where the raw numbers are. 21, 24, 27, all that. You guys with me back there? And then up here I'm going to put the z-score. So z was 1.33, and that means, what does the 1.33 tell us? We're 1.33 deviations above the mean, right? So 1 deviation above would be 24. We're a little more than that. And then what percent of the data is over here? 90.88%. So that's what I want for all the problems I'm making. We'll do another one together just to get you an idea. But find the z-score. So I'm trying to get you to learn how to find the z-score, put it on a graph so you kind of know what it means. Learn how to find the percentile, put it on the graph so you know what it means, and just kind of tile those things together. All right, questions on any of what I just did? Let's do another one. Let's say average height for males is probably 70 inches. Oh, I did this in the warm-up, didn't I?
Yeah.
That's all right. Whatever. Standard deviation of 4, let's say. Packard is 64 inches tall. I want to find his z-score, his percentile, like what percent of males is he actually taller than? and then graph it. So will his z-score be positive or negative? Negative, because he's below the mean. Will his percentile be bigger than 50% or less than 50%? Less than 50% because he's not taller than that many people. And then we graph, so yeah, let's just do it all together. So z-score, this is the last one I'm doing for you. You're on your own. Do want you to write the formula every time. X bar minus mu over sigma. You will probably write that down 1,000 times this year. Sorry, not sorry. What's X bar? 64. What's mu? 70. Sigma is 4. And so it comes out negative because our data point is below the mean, so you're subtracting a small number minus a bigger. That's how we get a negative. So it's negative 6 over 4. So negative 1.5 is our z-score. Then I'm going to find the percentile. What's the calculator command for that? Second dister. And then normal CDF. And I want to know everything below negative 1.5. So that starts at like negative infinity. Negative 99999. And I want to go up to, I'm doing it again. Go up 64. So I want to find 64 inches and everything below that. That's what this is trying to accomplish here. Then tell the calculator the mean and label it. Tell the calculator standard deviation and label it. Go ahead and type it in. You should get 0.0668. Make sure you're getting what I got. If you got an issue, let me know. Calculator issue, math issue, understanding what's going on issue. Yeah.
Does the order matter?
Yes. So the calculator always wants the lower number first. And then the higher number, so we're looking in between those two spots, and then the mean, and then the standard deviation. So it has to be like the way that they're ordered. Yeah.
Does it matter how many times you use?
Not really.
Mine does negative 1 to the times 10 to the negative.
Yeah. So the risk is like that tail on the side, like never really gets to the axis. So the further you go, the more of that you're capturing. But at some point, it's so small it doesn't even matter. That makes sense. All right, now graph it. So the average was 70. Standard deviation is 4. So I'm labeling my graph based on those standard deviations. And then I'm labeling Mr. Packard on here. He is 64 inches, so X bar equals 64. I'm labeling my z-score. And then you can kind of shade that in and say, okay, that's 6.68% of my data. Or like up here, I shade that in, and okay, that's 90.88% of my data. So Mr. Packard is, in this example, taller than almost 7% of men. He's a giant, basically. So that's the process I want you to be able to do and hopefully kind of understand how it all ties together at least a little bit at this point. Questions on anything in that process? Seem all right? So your homework is on Schoology. There are 8 of those. Once you get out a separate sheet of paper, do them on the piece of paper. And again, I'll walk around tomorrow, make sure it's done, and then we will move on. You have the rest of the time to do that, and I'll pass out the sheets with the corrections. No, you're in it.
Yeah.